Hello, welcome back. Today I will solve LeetCode 1514, path with maximum probability. We are given an undirected weighted graph. The probability of traversing from one node to another is the edge weight. Example here, the probability of going from 0 to 1 is 0.5. From 0 to 2 is 0.2. We are also given the start node and the end node. And our task is to find the maximum probability of going from the start to the end node. And if that is not possible, then we have to return 0. The edge weights are different for different edges, and they are all positive. Under these circumstances, we can deploy Dijkstra's algorithm. Okay, let's set this up. We will need several data structures. First, we need an adjacency list. That would be in terms of a dictionary or hash map. The key would be the node, and the value would be a list of tuples. The tuple will comprise the node and also the probability of traversing from the node to the neighbor. For example, 0, 1 has a weight of 0.5, and 0, 2 has a weight of 0.2. We also need a max heap that also will store a list of tuples, comprise the node, and weight. And the weight here is the probability of going from the source node to that node. I also set up an array where we're going to store the maximum probability of going from the source node to every node on the graph. And I set the base value to be minus 1.0. If it's a negative number, we know the maximum probability for that node has not been determined. We'll deploy Dijkstra's algorithm. This is the template that I discussed in video 1 of this series. If you have not watched that video, or if Dijkstra's algorithm is new to you, I would strongly recommend that you watch that video first. The first step, we push onto the heap the source node and the weight of 0. And then we are in the while loop, and we take the first item off the heap, that's 0, 0. And then we're going to do an update of the maximum probability table for the 0 node. And we're going to change this value to 0. And now we're going to get all the neighbors of 0, which are 1 and 2. We'll make a tuple of these nodes. Inside these tuples, the weight is the probability of going to the neighbor's node to the source node. Now, since 1 and 2 are direct neighbors of 0, the source node, the tuple weight are 0.05 and 0.02 respectively. And we put these on the heap. The heap is a max heap, so we will sort the tuples by weight, and the tuple with the max weight would be on top of the heap. So the first item, the top of the heap, is 1, 0.5, and we take that off the heap. And we do an update on the maximum probability table for the node 1 as 0.5. Now we get the neighbors of 1, which are 0 and 2. Now 0 we don't care because we already established the maximum probability of the 0 node, so we want to get 2, and we want to make a tuple for the node 2. The weight inside the tuple is the probability of reaching 2 from 0, and we check the maximum probability table. The maximum probability of reaching 1 is 0.5. So we know the probability of 1 to 2 is 0.5. So 0.5 times 0.5 is 0.25. So 2, 0.25, this tuple goes onto the heap. We are doing multiplication here because the probability of both of these events happening together can be calculated by multiplication of the probability of each event occurring alone. This is known as the product rule. Again, we are at the top of the while loop. The heap sorts the tuples by weight, and the maximum weight here is 2, 0.25. And we take that item off the heap. And we do an update on the maximum probability table for 2 as having 0.25. And now we take all the neighbors of 2. The neighbors of 2 are 0 and 1, so all these has been updated. We're not going to put anything on the heap. And again, we'll be at the top of the while loop. And we're going to take 2 off the heap. And since 2 is already updated, we are done. When we consult the maximum probability table, we will know that going from 0 to 2 would have the probability of 0.025. And that's the answer that we want to return. Now that we have discussed the pseudocode, let's talk about the real code. This C# implementation is available in the GitHub links below. For the adjacency list, we use a hash map, and in C#, this is a dictionary. We also have the priority queue, that is our max heap. And the maximum probability table, that's in the form of an array. And I set all the nodes having a base value of -1, as discussed earlier. Now, this part of the code, that's just to populate the adjacency list. Here, I put the start node with probability of 1 on the heap. And the weight here, I put 0, but it could be any value, because what we're going to do later is we're going to take the weight inside the tuple as the probability we're going to use to update the max probability table. I also put this line here. When I update the max probability table, I want to see the current node, whether that is the end node. And if that is the end node, then I will return the probability. And finally, after I exit the while loop, if I have not found the end node, then we cannot reach the end node from the start node. So I will return 0 as the probability of reaching the end node from the start node. Now let's test if this works. And it looks good. Next time, we'll try another problem using Dijkstra's algorithm. Hope to see you then.